We've got some questions here which involve similarity and scale factor. So the first question actually asks us to work out the scale factor involved in some different transformations. To do this, we just use our ruler and we're going to make some measurements. So if I measure a side length on this trapezium here, it looks like about 1.8 centimetres along there. I'll measure the same length, corresponding length on this larger trapezium. It measures 2.7. I'll be able to work out the scale factor involved, because the scale factor is equal to the ratio of the length on the image divided by the length on the original. So in this case it will equal 2.7 divided by 1.8, and that will give us a scale factor of 2.7 divide 1.8, 1.5. So this trapezium is the same shape as this one, but it's 1.5 times bigger. Its dimensions are 1.5 times the size. Let's have a look at this one here. Scale factor is equal to any length on the image divided by the same length on the original. So if we were to look at the length of one side of this pentagon, well, that's 2 centimetres. Same side on the image, 1 centimetre. So in this case the scale factor is the length on the image is 1 divided by the length on the original is 2. That's a scale factor of 0.5. Notice that in an enlargement the scale factor is bigger than 1. In a reduction the scale factor is smaller than 1. We've got a photographic enlargement in the next question here. Photograph which measures 6 by 4 is enlarged using a scale factor of 2.5. That means everything on the image or the enlargement is 2.5 times the size that it was on the original. Find the length and the width of the enlargement. Well, the length will be 2.5 times what it was on the original. So its length is going to equal 2.5 times it was 6 centimetres long. Now 2.5 times 6 is equal to 15 centimetres, and its width is going to be 2.5 times its original width, which was 4. 2.5 times 4 equals 10, doesn't it? Of course it does. Okay, how long would a ladder be on the enlargement if it was 3.1 centimetres on the original? Again, everything in that photograph is 2.5 times its original dimensions. So if it was 3.1 centimetres on the original, on the enlargement it will be 3.1 times the scale factor of 2.5. Works out to be 7.75 centimetres on the enlargement. Now this is a little bit trickier. How high will a pot plant be on the original if it measured 4.2 on the enlargement? This time we've gone the other way. So it's going to be smaller on the original, obviously, than what it was on the enlargement. Now, if the scale factor that we used for enlargement was 2.5, and we multiplied by that factor to get the size on the enlargement, if we want to go from the enlargement back to the original, we're going to have to do the opposite of multiplying by 2.5, which is dividing by 2.5. So on the enlargement it was 4.2, and this time I'm going to want to divide by 2.5 to find out the size on the original. Works out to be 1.68 centimetres. I'll just set up the paper for the bottom bit. And here we've got some similar triangles. This triangle here is the same shape but a different size than this one here. You could tell that there because all the angles in this triangle match up to the angles in this triangle. If we want to use scale factor now to work out the sizes in unknown sizes in them, what we should probably do is work out the scale factor when we change from the smaller to the larger. So in doing that, the scale factor is equal to, remember, it's the size on the image divided by the size on the object. So these are corresponding sizes. So 12 centimetres on the image was 10 centimetres on the original. 12 divided by 10 equals 1.2. Or in other words, everything on the big triangle is 1.2 times the size that it was on the small triangle. So if you want to find out size x here, x is equal to 1.2 times the size it was on the original triangle. This is its position on the corresponding position on the small triangle, on the original triangle. Now we've blown it up to be this size by a factor of 1.2. So it was 14 centimetres on the small triangle times by 1.2 to get its size on the large triangle. Equals 16.8 centimetres. Now I have to be a little bit careful with the next one because we want to find y, and y is on the smaller triangle. I'm not going to want to multiply it by 1.2. The larger triangle is 1.2 times the size of the smaller triangle, but now we've got a size on the large triangle, we're going to need to divide that by 1.2 to get the size back on the small triangle. .15 centimetres. Okay, let's have a look at the next example over here, and firstly let's work out the scale factor. These are similar triangles. This triangle and this triangle are the same shape but different sizes. You could do a bit of geometry and say that this angle here matches this angle here. They have to, they're what we call alternate angles. This angle matches this angle because they form the Z, we call them alternate angles. And the same with this one here, we've got this Z shaped here, so that means that that angle and that angle have to match up. Now when you've got triangles which have got three matching angles, they must be similar. They must be the same shape, but possibly a different size. And that's what we've got here. So the first thing to do is work out the scale factor involved. Now this side is one which matches this side. So that means that we can work out the scale factor. Work out the scale factor going from the small to the big, and in doing that we'll put the image size over the original size. So it's 10 over 4, and 10 divided by 4 equals 2.5. In other words, everything on this larger triangle is 2.5 times the size it was on the smaller triangle. That'll help us work out x. X is on the larger triangle, so I'm going to want to multiply it by 2.5. That's the side that it corresponded to on the small side. Notice this triangle here is kind of a flipped over version of that if you look at where the angles are sighted. So this corresponds to that. Everything on the bigger triangle is 2.5 times the size it was on the smaller triangle. So I'm going to get its size on the original, 2 centimetres. And I'll times it by 2.5. 2 times 2.5 equals 5 centimetres on the larger triangle. Now with y though, y is on the smaller one. When you go from the small to the large, we multiply by 2.5. But now we've got a size we know on the large, and we want to know how big it is on the small triangle. So this time I'm going to want to divide by 2.5. .4 centimetres.